When we get a huge list of numbers, we want to make sense of that and find patterns. There are a lot of different things that we can graph. We can do experiments, we can graph data that we just collect. When it comes to experiments, I like to use my favorite scientific manipulative. Food. Sometimes we want to show a relationship between two data sets to see if there might be a correlation. A correlation between two data sets is not exactly causation. It might be, but sometimes it's another factor that causes that correlation. So here I have several pieces of candy, and I went through and figured out how many added sugars and how many calories per piece of candy. If you look at the calories on a package, it has calories and how big a serving size is. So 160 calories for 7 pieces. So for 7 Hershey's Kisses, there are 160 calories. And I also looked at added sugars. So it has sugars, there are a lot of naturally occurring sugars in a lot of things, and that's fine. It's part of life. But how much sugar did they add? Added sugars were 16 grams, right? So 16 grams of added sugar for 7 pieces. So I just divided that up. I did that with all of the candies. With miniature candy, 4 pieces per serving, so 170 divided by 4, and 16 grams of added sugar divided by 4. Reese's Peanut Butter Cups, probably one of my favorite. 13 grams of added sugars, so I followed it over, 13 grams of added sugars, 3 pieces divided by 3, 130 calories, divide that by 3 too. So it's important to know your serving size here. So I did the math there already, and I got this data. Now this table shows the correlation, but I want to graph it. I want to see if there is some kind of correlation I could draw from that. So since I want to see a relationship between two numbers, I'm going to make a scatter plot graph. So I'm going to do my added sugars on my x-axis here. Even though I didn't make the candy, the amount of sugar that you add is something that is manipulated. So I'm going to do added sugars down here and calories up here. Okay, so first I'm going to label my axes. Added sugars in grams here. I'm going to write calories over here. Calorie is already a unit of measurement. It's how we measure energy. Sometimes we'll also use joules, but I didn't convert them in this case because time. What's my range? My lowest amount of added sugar for just one M&M would be 1.2 grams. And it goes all the way up to 4.3 for both Milk Chocolate Kisses and Reese's. So these are each 4.3 grams of sugar. Okay? So 4.3 minus 1.2, that's 3.1 is my range. So I'm just going to divide that. That would give me about 0.19. I can round that up to 0.2. So what I'm going to do here is I'm going to start right here. That's going to be 1.0. So we start 1.0, we go to 4.4. That is a good spread of my range. All right, what's my calorie distribution? I have 2.7 at my low end all the way up to 43.3. So my range here on calories is 30.6. So I'm going to go with 2.0 calories here. 2. So I'm going to do it in 2 calorie increments. And I'm going to start down here at 12. So I got 2. I started with 12 down here. So I'm just going to point out here. So 1 gram of sugar and 12 calories. All right, so then I'm going to make dots that show the relationship. So 1.2 grams of added sugar is 12.7 calories. So I'm at 1.2 and about 12.7 would be right around there. I'm going from the bottom apparently. So 4.3
is 43.3, 4.0 is 42, 4.3 is 22.8.
So you can see it's not a direct correlation. There's an outlier here. So when you draw a line, you don't want to connect the dots. This is a scatter plot, so you'd never connect the dots. You do a best fit line that shows the average. So we have 2 up here and 1 down here, so I'd probably do a line that kind of went like that. Could make it more linear than that, but I can't draw, so. Now we can do the same kind of thing with the original amounts with a per serving size, because that was per candy. So let's try it with a serving size real quick. Same steps. Okay, so now we have our data set up by serving. So let's do some correlation points. Let's start with the top. 16 grams of added sugar per serving is 160 calories. So we have 16 here and 160 right there. 13 again, but 170. 13 and 130, and 13 and 140. Then we want a best fit line to kind of go between the two. So it looks like there's some kind of correlation. I mean, the ones that have a lot more sugar have a lot more calories, but it's not a one-to-one ratio. There are obviously other factors. But wait, there's more. We forgot a title. Now, in this graph, we're showing the relationship of calories to sugar per serving. Per serving. All right, so I specified that this is per serving. And this one, we have the same kind of data, but it's per piece of candy. So I'm going to write so I'm specifying here. So I have two different graphs and they show different data. So I have to specify in my title, this is per piece of candy. So for one of each of these. And this one's per serving. So 3 of these and 4 of these. So it's important to specify in your chart, is it per serving, per piece? You got to make sure you show why these graphs look different. What's different about your data, or data, however you want to pronounce it. Okay, let's do a bad example of a graph. Sometimes at the beginning of the school year, all of my students do a lab where they take different types of dish soap and they see how big of bubbles they can make. And then I have them record their data and graph it. And sometimes I get something that kind of looks like this. They connect the dots and there are several other problems. So how many problems can we find with this graph? There should be several. Where do we start? Well, let's start with one of the more subtle things. Bubble size. That doesn't tell me much about the experiment. I need to look at the title and know what happened. So maybe bubble size of dish soap on a table. In this experiment, I usually have them put a little bit of dish soap on the table, take a straw, and blow a bubble and see how big the bubble can get. Then I have them measure the diameter. First of all, what they're changing is the dish soap. So this should be on the x-axis. The type of soap should be down here. This is how big the bubble was, but it's not labeled. So we need to label this axis. So this should be something like diameter of bubble. And what did they measure it in? There's no unit. So it'd have to be in centimeters. And again, this would go here. All right, so putting the data points, correlating the points makes sense, but there's no reason to be connecting this. There are a couple ways you can do it. The easiest way would be to compare the two groups, would do a bar graph. So this is the wrong kind of graph. So they need to do a different type of graph, because when you do a bar graph, you compare the two groups. You can even do a histogram because it shows a distribution of the bubble size. Another thing is, this is not evenly spaced out. We have 3.2, 3.7, so there's a 0.5 centimeter difference here, 0.1 here, but it's the same length, so it totally is misleading. So even units. Okay, so this needs to be labeled properly. There are a lot of things wrong with this, but that's okay. We go back and we fix it. Now they can redraw it or they can do it in Excel. So how would I better graph this type of data? Well, here I have my data here. I have type of soap and I have my bubble size. And you may notice these is a little bit different. Each of these I did equal and then I did an equation. And then when I hit enter, it just does the math for me. So I had 3 data points. So I added those together, put them in parentheses and divided by 3. Remember, it's an average. So you divide by however many data points you have. So I did that for all of these. And see, I put the equations in there. When I hit enter, it just gave me the size. So if I want to graph that in Excel, I'm going to highlight it. And then I'm going to do insert. There are a bunch of different options for graphs here. Now I want to do a bar graph, a column. So I'm going to click on that. Beauty, right? Well, this isn't exactly all that I want. So what I'm going to do is I'm going to click chart right up here. So what I'm going to do is I'm going to start with the chart title. See, it says there is none. I can get rid of it. I can do an overlay, blah, blah, blah. I'm going to edit the chart title I have. I'm going to do size of bubble for various types of dish soap. Capitalize those. All right. Okay. There we go. Beautiful. All right. So now I want to label my axes. So I do access, see here it says access titles. All right, horizontal axis. Okay, so horizontal, remember that's left to right, the x-axis. Types of soap. Okay, types of soap. Alternatively, what I could do is get rid of that and then I could do format instead of series. See, I clicked on there and I hit format. So instead of series, I could just do types of soap. That would work too. Beauty. All right, so I still am not done. I want to label my vertical axis. So again, I click chart up here, axis labels, vertical axis. So I can have none, which is what I have now. I have a rotated title or a vertical title, so the letters go down, horizontal, blah, blah, blah. I want a rotated title. So I'm going to write diameter of bubble. And always remember to put your units, otherwise the data doesn't mean anything. Okay, beauty. So now I have a title. Now I have my x-axis, my y-axis. You know, actually I'm looking at this. I don't want this to say types of soap, so I'm going to change that. So instead of types of soap, we're just going to write bubble. In my chart, I'm going to do axis, horizontal axis. Okay, so there are types of soap, we have our bubble sizes, and we have the diameter of the bubble in centimeters. So that's a much better chart. That's a much better way of representing this data. Now keep in mind, if you have data over here, whatever you put on the left side will go to your x-axis, and the right side will be your y-axis. So remember that when you're charting this, and then you would just highlight it, and then you pick what kind of graph you want to do, and then you'll have to make adjustments.
Sometimes you'll do a graph by hand, and sometimes you'll use a computer. It's important to know how to do both. Just remember when you're graphing, you look at your data first and then figure out what kind of information you're trying to convey. If it's change over time, then you use a line graph. If it's a correlation of two variables, then you use a scatter plot. If you're comparing groups, it's a bar graph. If you're showing a distribution of data, it's a histogram, not Instagram. If you're showing parts of a whole or percentages, it's a pie graph. Graphs are super helpful and useful in showing a variety of data. Yay, graphs!